Hey guys, this video lesson is all about graphing basic rational functions. Rational functions are these functions that are made up of fractions where we can have variables in the denominator. The parent function y equals 1 over x has two asymptotes. It has a horizontal asymptote at y equals 0, and it has a vertical asymptote at x equals 0. We learned that it has a branch in the lower left-hand quadrant, alright, and another branch in the upper right-hand quadrant. Okay, on a graphing calculator it looks something like this. Now, when you take the parent function and you subtract 5 on the end like this moves the function down 5. And when you add 7 on the inside of the function like this is a left-right motion, but specifically this is left 7, alright, which is probably the opposite of the way you were thinking. So compared to the parent function, this function is left 7 and down 5. Okay, because of the left 7 part, we have to take this asymptote and move it, grab the whole thing. We have to take this asymptote and move it 7 to the left. So 1, 2, 3, 4, 5, 6, 7. Because of the down 5 part, we have to take this asymptote and move it down 5. 1, 2, 3, 4, 5. Okay, so this is the proper placement of the asymptote. Now, the vertical asymptote helps you know which values to pick. So try to put your vertical asymptote in the middle of the graph if you can. So since the vertical asymptote is here at -7, then we will put -7 in the middle of our graph. That makes this -6 and -5. Actually, that's going the wrong way. That makes this -8 and -9 and -6 and -5. Okay, of course the vertical asymptote will be undefined. Okay, because think about it. If x were -7, we would have -7 plus 7. That would make 0 in the denominator, and you can't divide by 0. Okay, now we need the y values that go with this. For now, let's just use the calculator, but eventually you'll have to be able to find these y values by hand without a calculator. So 1 over x plus 7 minus 5. Okay, so let's go to -9. Alright, at -9 we have 11 over 2. We'll toggle it to see the decimal. So that's -5.5. And -8 is -6. Alright, of course -7 is the asymptote. And then at -6 we have -4. And -5 we have 9 over 2, which of course is the same thing as -4.5. Okay, let's plot these points, people. So -9, -5.5. Okay, so this would be -9, -5.5. Okay, and then -8 and -6. Okay, these 2 points are enough to help me sketch my little branch right here. Okay, now -6, -4. So here's -6 and here's -4. And -5, -4.5. Alright, and these 2 points will help me sketch the graph as well. Okay, now I'm messed up in this area a little bit, but you get the idea. Your graph should look something very much like this, approaching the asymptotes as we go in every direction. So now let's take a look at the domain and range. The domain is how far it goes from left to right. It's the x values. So this graph goes left forever and right forever, but it skips over the vertical asymptote at -7. So we have to make sure that -7 is not included. Okay, so we will say -infinity to -7, and then -7 to positive infinity. In that way, and by using round parentheses, we can cleverly skip -7. Similarly, the range. Alright, the range is the y value, so we're looking from bottom to top. And every y value is covered except for the horizontal asymptote. So we have to include all y values except for -6. Is that right? 1, 2, 3, 4. Oh, -5. Right, because of that. Everything except for -5. So that's why the range is going to be from -infinity to -5, and then from -5 to infinity. Okay, of course the asymptotes, we have a vertical asymptote at x equals -7, and we have a horizontal asymptote at y equals -5. Okay, and I believe that is it for problem number 1.
Hello, everybody. I wanted to say hi and remind you guys, listen to Daddy, but don't copy Daddy.
Thank you, sweetie. That is very helpful. Okay, problem number 2. This time there's no shift up or down. But this -3, what's that going to do? That is going to shift right 3 compared to the parent function. So since we're shifting right 3, that means that the vertical asymptote, which normally would be at 0, will now be right 3. So it'll be over here. Alright, so there's my shiny new vertical asymptote. And because there's no vertical shift, alright, we're not moving up or down, we will still have an asymptote at y equals 0. Okay, the vertical asymptote lets us know which x values to pick, because we'll put this vertical asymptote of 3 in the middle of our graph if we can. Okay, so here goes the vertical asymptote. That means I will have other x values of 2 and 1 and 4 and 5. To get the y values that go with these x values, for right now I'm going to use the calculator, but be prepared to do this by hand if you have to. Let's see, what about that table? Okay, so we're supposed to start the table at 1 actually, so at 1 we have -2 and then -4. So at 1 we're at -2 and then we're at -4. Okay, these 2 dots are enough to tell me where to graph this branch. And it's something like this. Whoa, I went far. Alright, let's take a look at the other branch. Wait, what happened to my values? Alright, my other two values are 4 and 2. Okay, so picking up at 4, comma 4. So that's going to be, so here's 4, comma 4. And 5, comma 2. Alright, and these two values are enough for me to draw a pretty good branch. Alright, so that's what your graph should look like. The domain and range. The domain is all x values except for 3. Got to skip over this vertical asymptote. So if I want to do all the x values except for 3, I can get that done by doing negative infinity to 3, and then 3 to positive infinity. Right? Everything except for 3. Similarly, the range is all y values except for 0. So bottom to top, always start with your negative infinity. Okay, so that's going to be negative infinity to 0. And 0 to infinity. Okay, of course we have a horizontal asymptote at y equals 0. And our vertical asymptote is x equals 3. Okay, that's it for problem number 2. Let's see it. Problem number 2. Oh yeah. Okay, how about problem number 3? Alright, for problem number 3, compared to the parent function of f of x equals 1 over x, we have a couple of changes. Alright, we learned that adding 4 on the end is going to move the graph up 4 compared to the parent function. It's been a while since we talked about the fact that having a negative sign on the leading coefficient is a reflection in the x-axis. Okay, so these branches, like we normally have this a branch in the lower left and another branch in the upper right, these may be reversed because of the mirror effect of the negative 2. Also, it's a 2 instead of a 1. So that is a vertical stretch, but you know, unless you're comparing it side by side, you might not notice. Alright, but let's start with the fact that the horizontal asymptote is going to be up by 4. And let's put that in the right place. Alright, on the other hand, there is no left or right motion. So the vertical asymptote is still going to be x equals 0. Alright, so there you go. Now that vertical asymptote really tells us which x values we need to use. I like to put the vertical asymptote number right in the middle of my chart. In this case, we have a vertical asymptote at 0. So I'm going to put 0 in the middle and put undefined. Okay, going less than that, that would be negative 1, negative 2. Greater is positive 1, positive 2. Okay, let's get the y values that go with it. Okay, so negative 2 over x plus 4. Okay, where was I supposed to start again? We had agreed to start at negative 2. Okay, so at negative 2 we're at 5 and 6. Okay, this is 4. So at negative 2 we're at 5 and 6. Okay, and then how about 1 and 2? Alright, at 1 and 2 we're at 2 and 3. Okay, now these dots are enough for me to draw the sketch. Alright, so number 3 should be looking something like this. Now how about that domain and range? Alright, again the domain is the x values. we have all x values represented except for the vertical asymptote at 0. Everything but 0. That's why the domain is going to go from negative infinity to 0, and then skip over 0 and go from 0 to positive infinity. Okay? Mosquito just attacked me. Threw me off my game. Alright, similarly the range. The range is the y values. We have all y values covered except for the horizontal asymptote. We have to sort of skip over that. So everything except for 4. So that's why we're going to go from negative infinity up to 4. And then we're going to skip 4. And we'll go from 4 to positive infinity. Being careful to use round parentheses for around the 0 and the 4 so we don't include the 0 or the 4. Of course, our asymptotes were, we had our horizontal asymptote is always y equals a number. In this case, y equals 4. Alright, the vertical asymptote is always x equals a number. In this case, x equals 0. Alright, and that sums it up for problem number 3. Excuse me. Let's see. 2 more problems left. You know what, this is just going to have to be a long video. I don't feel like splitting it up. I'm really sleepy. We're just going to have to power through. Alright, let's talk about the transformations on number 4. This 1, compared to the parent function, will be up 1. This minus 2 will send us to the right by 2. Notice it's the opposite of what you would normally think. This negative sign right here is going to be a reflection. I spelled that really badly. It cannot be salvaged. Let me try it again. Reflection. Okay. And technically this 3 is a vertical stretch. So, if this is gonna be up 1, that's going to affect the horizontal asymptote. Okay, so in other words, the horizontal asymptote, which I'm just going to abbreviate HA for right now, horizontal asymptote, is going to be y equals 1. Hey, I meant that to be gray for some reason, but it wasn't. Okay, there's the horizontal asymptote. And since we're shifting to the right by 2, okay, that's going to affect the vertical asymptote. The vertical asymptote will be x equals 2 because of that. Okay, so let's have our vertical asymptote at 2 and our horizontal asymptote at 1. Okay, the asymptotes. Now the vertical asymptote goes in the middle of our chart. Okay, so I'm going to put 2 right here because we always put our vertical asymptote there in the middle. And that will be undefined. Okay, if this is 2, then that makes this 1 and 0 and 3 and 4. For right now, let's just use our calculator to find the y values. Okay, I think we were supposed to start at 0, I do believe. Yep. Okay, at 0 we have 5 over 2. Okay, that is 2.5. Okay, and let's see, at 0 we're at 2.5. Great. What about 1? At 1 we're at 4. Alright, that's enough to draw the curve. Alright, how about the other values? Okay, 3 and 4 are -2 and -1/2. Okay, so that means at 3, I'm at -2. And at 4, I'm at -1/2. Okay, so now I'm going to draw that branch. Alright, it should look something like that. Okay, how about the domain and range and asymptotes? Well, the domain is the x values, alright? So we have all x values except for positive 2. So that's why the domain is going to go negative infinity to 2 union 2 to infinity. Okay, that's everything except for 2. The range goes from bottom to top. It's the y values. And this graph contains all y values except for 1. Right? We have to skip over that horizontal asymptote. So the range will be all y values except for 1. So that will look like this. Negative infinity to 1 union 1 to infinity. Alright, we have a horizontal asymptote at 1. So that's y equals 1. And we have a vertical asymptote at 2. Okay, so that's x equals 2. Alright, number 5. Write a rational equation with asymptotes at 5, x equals 5, and y equals negative 3. Okay, so please understand, x equals 5, that's a vertical asymptote. Okay, if we're going to have a vertical asymptote at 5, then what we need is we need for the asymptote, which normally is at 0, to be shifted over to 5. So we need this thing to be shifted to the 5 to the right, so that the new vertical asymptote will be 5. Okay, and how do we get this thing shifted 5 to the right? Why does this keep going? Oh, my pad was slanted, so I'm like, why is everything slanting down? Let me start over. So we have f of x equals, we need this thing to slide to the right, so it'll take x minus 5 in the denominator, will move the vertical asymptote, which normally would be at 0, but it'll slide to the right 5 if I have minus 5, just like this slid to the right 2 because I had minus 2. Okay, so I've got my vertical asymptote happening now. Okay, so far that's all I have. Right now, the way it is, my horizontal asymptote is at 0. So please understand that y equals negative 3, y equals the number is a horizontal asymptote. Horizontal. Okay, so the horizontal asymptote is usually at 0. So if I want it moved to negative 3, that's down 3. And the way I move the graph down 3 is by sticking a minus 3 on the end of this. So that would move me down 3, horizontal asymptote y equals negative 3, and to the right by 5, vertical asymptote x equals 5. So mission accomplished. Okay, this number up here could have been 2 or something else, but this gets it done. Alright, is there anything else in this lesson? I don't want to miss anything. Alright, I think we did it. I think that's going to be the end of this lesson, guys. I hope it was helpful, and I look forward to seeing you on the next video.